the 2-2. Yesterday, like I said, we took this generic statement and we wrote it as an if-then statement. If you remember from your notes, it's probably sitting right there, we said perpendicular lines intersect. Our if-then statement was then, if two lines are perpendicular, then they intersect. Remember that? So if two lines are perpendicular, then they intersect. Now, you guys might want to write this down. You haven't been here for a long time. Make sure you write these things down, okay? Do we agree that this is a true or a false statement?
True.
It's true, okay? So what this becomes what we call a conditional statement. And yesterday we talked about it as P implies Q. Remember that? Where P is our if, Q is our effect, what's going to happen. Our if, then. P implies Q. We use this, what's called a conditional statement, to come up with three other what are called logic statements. And I like to use this P and Q stuff because it's easier to follow along. So we have what's called a conditional. And that's what you're always starting with. It's your first if-then statement. It always stands for if, then. P implies Q. The next one is if you flip-flop it. It's called converse. Q implies P. You basically say it backwards. If two lines intersect, then they are perpendicular. See how that works? If two lines intersect, then they are perpendicular. Now, is that a true or a false statement? False. Why is that false? Exactly. So we agreed the first statement was true. Oops. Our first statement is true. Our second statement is false. And remember, anytime we come up with some sort of a false statement, what I want you guys to do is always use what's called a counterexample. Okay? We're always going to use a counterexample. Not doing our homework for tonight right now. Let's worry about taking the notes for it first. And you said it could be lines that intersect that don't form right angles. So I could just draw something like this. And I'm good. Just two lines intersecting. They're not perpendicular. How would you show that lines are perpendicular in a diagram? What would you have to have? That square thing, yes. You gotta have that little square box in there. As long as it doesn't have that, it means that they're not perpendicular. Make sense? Correct. There never has been. I don't know. Never thought of it. That's just the way that they've always shown it, that they've never meant it to be any other way. That's all. Okay? So, conditional, P implies Q. Converse, flip it. Q implies P. The next one is what we call an inverse. And in the inverse, you have to do what's called negation. You have to negate. Basically, negate is a fancy word for saying not. That's it. So what we do is we put the word not into the conditional statement. If two lines are not perpendicular, then they do not intersect. Yeah. If then. I don't know. It's just how it started. It's a logic statement. They came up. Remember, I think I talked about this yesterday when there was an old saying, "Mind your P's and Q's." It's about be careful how you argue. It's be valid, kind of what it was. And I'm sure it has something to do with Latin. I don't know. I'll find out. I'll let you know. Arabian yes. Or the Greeks. So the inverse here, I'm going to show you another new symbol. What we do is we use this. Not P implies not Q. Where this upside down backwards 7, that stands for the word not. Sometimes they use a tilde, means the same thing. I'll put this over here too for you guys. So we have conditional. Conditional is your original. P implies Q. Converse. Inverse. Not P implies not Q, where this symbol means the word not. The reason why I wanted to show you that they sometimes use the single squiggly for that also is I think there is one page in your textbook as you're scrolling through stuff. They do a thing about truth tables, and they use the tilde symbol, the single squiggly, to show negation. Other than that, it doesn't happen very often with that symbol. It's usually that upside down backwards 7 is usually how they show negation. Okay? Now, if I use this inverse, I go back to the original statement. If two lines are not perpendicular, then they do not intersect. That's what that would look like. If two lines are not perpendicular, then they do not intersect. Excuse me. Thank you. Is that a true or false statement? Why? Give me a counterexample. Why would this be false? Two lines are not perpendicular, but they do not intersect. Yeah. Yeah. But they do not intersect. These would show me that they intersect.
Oh, do not.
Yeah. Two lines that are not perpendicular do not intersect. That's false because you can have parallel. So if they're not perpendicular, they're not going to intersect. So that's also another false statement. One of the things that can happen that you'll start to see through here is that you could probably, let me see, two lines are not perpendicular, they do not intersect. So they're not perpendicular, they don't intersect. Well, you could have, when you were saying that you could do how they cross again also, that means the same. You could have used that example as well. Because if you have them where they're not perpendicular, they do not intersect, well, these are not perpendicular and they do intersect, so you're negating the whole thing also. That would have been a valid argument. I had to think about that for a second, sorry. What happens a lot of times with these types of statements, the middle two parts, that converse and inverse, are generally false. Okay? They're usually false. There are very few times that they are true. There's a special case for that. I don't know if we'll have enough time today to talk about that case, but who knows? We'll play it by ear. And then the last one is called the contrapositive. And I know the vocabulary here is a bit of a pain, but if you keep these in the same sequence of P to Q, Q to P, not Q, what do you think the next one's going to be? Look at the pattern of the letters.
Q to P.
Right. Not Q, not P. That's it. Not Q to not P. And that's how it works. And that's one of the main reasons why I like to write it out with the P's and Q's. Because if you remember, if you keep it in that sequence, it follows these four in order. P to Q, flip it. Negate it, flip it and negate it. And that's all it is. So this last one would be if two lines do not intersect, then they are not perpendicular. If two lines do not if two lines don't intersect, they are not perpendicular. Is that true or false? Yes, ma'am. That is true. That's true. Okay. Now, what's going to happen a lot with these things, guys, is that generally, if your first statement is true, your last statement is going to be true. And that's basically how a lot of logic stuff works. How you can come across and work with proofs and stuff. Now, I was telling the other classes about this. We actually haven't done a lot of this logic stuff the past few years. And one of the reasons is that it's kind of a pain. But the more we look at the way test scores and things work themselves out when you deal with proofs later on, we felt that it was a good enough topic to bring back in because of the fact that it starts your brains to think about the logic ways of how you can put sequences together. As much as this seems kind of laborious and tedious and whatnot, it actually is going to force you to think your way through an argument. And that's what's nice about it. Okay, that's why we do a couple of days of this. I think it'll pay off next week and the week after. We start doing a little bit more proof stuff, like with segments and things like that. So contrapositive, flip it, and there it is. Just like we did, anytime that you can come up with a false reference, you always got to give a counterexample. Whether it's just a picture of a diagram or something like that, or a numerical value or something along those lines, it works. Let's try another one. And angle, let me do it this way. Angle A equals 100 degrees. If angle A equals 100 degrees, then it is obtuse. That's a conditional statement, starting you off. If an angle A measures 100 degrees, then it is obtuse. Is that true or false? It's true. That's an obtuse angle. So how would you say that backwards? I probably shouldn't have put. Probably didn't have to put it in the angle A part here. If I just say if an angle is 100 degrees, is it just that we don't have to label it as angle A? If an angle is 100 degrees, then it is obtuse. So if you go backwards, whoop. Oops, so I know how to spell. Is that true or false?
False.
What's your counterexample?
You can have an angle that's like 120.
There you go. The angle would be 120. That's all you gotta write. Okay. Miss Tope, you went cross-eyed. What's wrong?
It just seems like it was easier. Like it's easier to jack it up.
Oh, there was. You had the look of anger. That's why. So you were mad that it's easy? Is that a no as in a question or a no as in
She was like,
definite?
wow, that's actually.
That's exactly.
Okay, wait, I'm confused why it's, what?
What's that?
I'm confused why it's false.
If an angle is obtuse, what you're saying here is that if an angle is an obtuse angle, then it's going to measure 100 degrees. What do obtuse angles measure? Well, could it be 90.00002? Could it be 79.999999994? Between 90 and 100, that 100 is all you can provide. Okay. But yeah, that's all it is. That's it. Go to the next one. Inverse. Not P, not Q. What would that sound like? Not P, not Q. Very good. If an angle does not equal 100, then it is not obtuse. We okay with me putting the slash through an equal? You guys remember the not equal? So if an angle is not equal to 100, then it is not obtuse. True or false? What's your counterexample?
Never over 90 degrees.
Could it also be like 3?
No,
It's not obtuse.
I said anything over 90 degrees.
Okay. Yeah, and that's the point of getting in here. A lot of times you can reuse the same. You can reuse the same one.
I'm doing
Wait, can you put any number besides 120? As long as it's-
it. Yeah.
As long as it's obtuse, yeah. Yeah, and what I'm trying to get at here is you don't have to come up with different counterexamples if the same one works. So if you already figured out one, and if you say it through it again, a lot of times it'll work out all right being the second counterexample. Then what would the last one be? The contrapositive, the not Q, not P. So if it is not obtuse, then it's not at 100 degrees. Is that true or false?
True.
Right. Does that make sense? If an angle is not obtuse, then it is not 100 degrees. And that's true. So again, notice the first and the lasts, those usually are going to mirror up to be the same. Okay, those usually mirror up to being the same. Don't get me wrong, there are like one or two that I think that I've seen that they don't. But generally speaking, the first and the last usually match up. Okay, they usually do. That's how most definitions work in geometry. That's how a lot of theorems are shown. Just for one really easy one. I want you to try this. Bless you. Remember what that meant? Meant congruent. Yes, ma'am. Fine.
Wait, make that interesting.
Yeah, what I want you guys to do is I'd like you guys to take a couple minutes. I want you to use the generic statement that vertical angles are congruent. I want you to turn it into a conditional if-then, and then go through the rigmarole of the other ones to see what you can come up with. Now everyone's going to be a little bit different because how you start. You're shaking your head. You don't think you'll be all right? Well, let's think. Vertical angles are congruent. How can you turn that into if then? A true one. Let's start true. Right, but there's no if and then in there, is there? So throw some if and thens in there and see what you come up with. Okay. Go for it. You got it.
I always have confused with vertical.
Opposite rays create lines.
Oh, yeah.
You had it. Write them through so you guys can come up with.
I don't know if I should do
Roll through this one real quick, see how we did. Conditional wise, P implies Q. Shh, guys, real fast here. If angles are vertical, then they are congruent. True or false?
True.
Say it backwards.
If the angles are
If
vertical,
angles are congruent,
then they are
true or false?
false.
Example.
Uh,
Don't overthink it.
let's do a 90-degree angle. No,
Okay.
14.
What if I did this? Is that two congruent angles?
Yeah.
To me, I like where you're going with the 90-degree angles. Could you have done and do that? Or you can do that and as long as you throw the tick marks in to show that they're congruent, that's fine. I was just thinking that I know that if I have a triangle, I can throw tick marks in a triangle for two angles and show that those two angles are congruent. Done. It shows it works. Now go the other way. Not P, not Q.
If an angle is not congruent, then it's not.
True or false? That's false. Can't they use the same example then too? And then the last one. If the angles are not congruent, then they are not vertical. Is that true or false? Correct. So, what I want you guys to work through tonight, guys, is the same section as 2-2. They are on, ladies and gentlemen, come on. I want you guys to do those 8 problems. You've got 4 of them where you're going to start with, they're going to give you a statement. You need to turn them into an if-then, your conditional, and then go through the roles of all 4 of these, okay? Please, when you're doing that, make sure you're writing down which one's which, along with your P's and Q's. That way it forces you to remember which ones they are. Ladies, please. And then with the last 4, it's another bout of definitions, working through them. There is no real math here. You're just looking to see if you have valid definitions or not, things like that, okay? Tomorrow, we will talk about what's called a biconditional statement. It's a statement that is true if you say it in the conditional sense or the converse sense. It means the same thing. Right angles measure 90 degrees. If you have a right angle, then it measures 90. If an angle measures 90, then it's a right angle. It's the same thing going both ways. That's called a biconditional statement. We will talk about that for about 5-6 minutes, and then we'll have a friendly competition on logic puzzles. See what you can come up with valid reasoning. Okay? So you know where we're at for next week then. When we get back from